Of all the various shapes that we might try to graph, circles are possibly the most important. Circles are ubiquitous in real life, they're ubiquitous in theory, and so we want to make sure to understand how we can recognize and graph an equation whose graph is a circle. We also want to know how we can take a circle and write down an equation that has that circle as its solution set. So let's think about how we actually describe a circle or define a circle. And we recall from geometry that a circle is the set of all points an equal distance from a center point. So if we want to define a circle, we need to choose a center of that circle, and then we need to say how far away all the points on the circle are away from that center point. This distance from the center out to the circle is also called the radius. So we need to choose a center and a radius. So let's take an example. Let's consider the circle with center at the point 1, 2 and radius 5. So let's see if we can sketch this out, and then we'll think about whether we can actually write down an equation where the circle is the solution set to the equation. Well, here's the point 1, 2. Here I'm using the tick marks on the grid as counting for 1. And now, if I want to find the circle with radius 5, one thing that I can do is move up, down, left, and right by 5 units in each direction. Like this. 1, 2, 3, 4, 5. And then the circle is approximately like this. Circles, famously difficult to draw freehand. So, bear with me. So here we have a circle with radius 5. Let me go ahead and note that radius as well. So if I take a particular point, x, y, that's on the circle, then what I know is that that point is a distance of 5 units away from the center 1, 2. So, in other words, we have that xy is on the circle if and only if the distance from xy to the point 1, 2 is 5. And fortunately, we have a formula for the distance between 2 points. So we know that the distance from xy to 1, 2 for any points x and y is the following. We know that the distance from xy to 1, 2 is equal to x minus 1 squared plus y minus 2 squared, and then we take the square root of that. So that means that the circle consists of all points x, y such that the square root of x minus 1 squared plus y minus 2 squared equals 5. Just taking the distance and saying we want the distance from the point xy to the center of our circle to be equal to the radius of the circle. And that's going to give us all of the points on the circle. All the points on the circle are a distance of 5 away from the center. Now, in order to make this a little bit easier to work with, what I'm going to do is I'm going to square both sides of this. And that's not actually going to change the solution set to the equation at all. So we're going to get x minus 1 squared plus y minus 2 squared equals 25. And this is the equation of the circle. Now I want to point out that there was nothing really special about any of the points that we chose, any of the numbers that we chose. There's nothing special about the point 1, comma 2. We could have used any point as our center. There's nothing even really special about our radius, except that, of course, it has to be non-negative. And so these three numbers here in the formula, the 1, the 2, and the 25, are going to change based on the center and radius of the circle that we're working on. However, the rest of the equation, the form of the equation, isn't going to change. And in fact, this is going to give us the standard form of the equation of a circle. So the standard form of the equation of a circle with center, I want to start with the center, with center at the point h, comma k, and radius r, is x minus h squared plus y minus k squared equals r squared. So this formula allows us to do a couple of things. It allows us to graph equations that are in this form, because we know that the graph of the equation will be a circle, and we can identify its center and radius. And this also allows us to start with a circle and find the equation that has that circle as a solution set. So let's take an example. Let's graph the equation x plus 3 squared plus y minus 6 squared equals 36. So the first thing we do is that we recognize this as the equation of a circle, because it's in the form that it's in our standard form that we just identified. So the next thing that we want to do is identify what the center and the radius of this circle are. Now remember, in the formula, the two terms, the x and y terms, are always x minus h, y minus k, where h and k are the coordinates of the center. So if I have x plus 3, I want to think about this as x minus negative 3, which means that our center is actually at negative 3, comma 6, because this equation is always in the form x minus h, y minus k, where h and k are the coordinates of the center. The radius of this circle is going to be the square root of the number on the other side, because this 36 is supposed to be r squared. It's supposed to be the square of the radius, which means that the actual radius of the circle will be the square root of 36, which is just 6. So we're looking at a circle with a center at the point negative 3, comma 6, and with a radius of 6. Let's see how we graph that out. I want to make sure I give myself enough room to do this. So first thing we want to do is we want to plot the center. So there's negative 3. And there's 6, and I didn't give myself enough room. 1 second. That's better. So here's the point -3, 6, which is the center of our circle. Now, what I like to do here is I like to move directly up, left, up, down, left, and right by the radius in order to get other points on the circle. So if I know that the center of the circle is at -3, 6, and the radius of the circle is 6, then if I move straight to the right by 6 units, I'm going to get a point on the circle. And if I move straight left by 6 units, I'm going to get a point on the circle. So that gives me the points 3, 6 and -9, 6, the 2 points I get by going straight left and straight right. Now if I go straight down, I'll get the point -3, 0, so lying on the x-axis. And if I go straight up, I will get the point -3, 12, going straight up on the graph. So that gives me the 4 sort of compass points on my circle, and from there I'll go ahead and sketch out what the circle looks like. And that's how we do it. Once we recognize that the equation we're looking at is in fact the equation of a circle, as long as we can identify the center and the radius, graphing it is a straightforward process of simply sketching a circle with a given center and radius. On the other hand, if I have a problem like the following, find the equation of a circle with center -3, -4, and radius 7, then I don't have to graph this, actually. I can just use the standard form of the equation. I take x minus h. H is the x-coordinate of my center. K is the y-coordinate of my center. R is the radius. And so my equation becomes x minus -3 squared plus y minus -4 squared, and that equals 7 squared. We'll want to simplify this down, of course, and so we'll get x plus 3 squared plus y plus 4 squared equals 49. And that's how you use the standard form of the equation of a circle in order to either find the equation based on the circle or graph the circle based on the equation. Now let's take this same equation here and let's rearrange it. So let's look at the equation x plus 3 squared plus y plus 4 squared equals 49. Of course, there are many equivalent forms of this equation. One standard one that we might use in a lot of cases is to expand everything out. Just FOIL out everything on the left and gather everything up. So if we do that, then we get another form of the equation. So let's go ahead and do that. If we multiply x plus 3 times x plus 3 out, we get x squared plus 6x plus 9. If we multiply out y plus 4 squared, we get y squared plus 8y plus 16. That gives us 49 over here. And now I want to rearrange this in a particular way. I want to get all my x's, my x squared and y squared in front, and then my x term and my y term. And then 9 plus 16 is 25. And then I want to subtract 49 from both sides in order to get the right-hand side equal to 0. And we get x squared plus y squared plus 6x plus 8y, and then 25 minus 49 is minus 24, and that equals 0. And this is another form of the equation of a circle. Now, of course, we can't read the center and radius of this circle off directly the way we could before. You'll notice that 3 and 4 and 49 don't appear in this form. Nevertheless, this is another common form that we see the equation of a circle in, and this is called the general form of the equation of a circle. So, the general form of the equation of a circle is x squared plus y squared plus cx plus dy plus e equals 0, where c, d, and e are all real numbers. So in our example up here, c was 6, d was 8, e was negative 24. If you choose any other numbers there, then you will get a potential equation of a circle, and we'll see in a minute why I say that it's only potential. So the question is, how do we find the general form of the equation of a circle, first of all? And the answer is the way that we did it before. We find the standard form and then just expand everything out. So, as another example, let's find the general form of the equation of the circle with radius 2, 4, with center 2, 4, and radius 4. So the first step is to use the standard form. The standard form of this circle, of the equation of this circle, would be x minus 2 squared plus y minus 4 squared, because 2 and 4 are the coordinates of the center, equals 16, because that's the square of the radius. And then step 2 is to expand. Step 3 will be to gather everything together on the left and simplify. So step 2, we expand everything. So x minus 2 squared becomes x squared minus 4x plus 4 plus y squared minus 8x plus 16 equals 16. So now we're going to rearrange things and gather things together. I'll just call this whole step simplifying. So we get x squared plus y squared minus 4x minus 8x, and 4 plus 16 is 20. And then we do need to subtract 16 from both sides, because the general form of the equation of a circle does require having a 0 on the right-hand side of the equation. So the equation of our circle in general form is x squared plus y squared minus 4x minus 8x plus 4 equals 0. So that's how we go from a circle to having the general form of the equation of a circle. The next question that we would want to ask is, all right, well, assume that we start with an equation in general form, how do we actually find the circle? How do we graph that circle? Let's say we want to graph the equation x squared plus y squared plus 6x minus 10y minus 14 equals 0. Let's suppose that we wanted to graph this, this equation. So what we would want to do is we want to rearrange this equation. We want to get an equivalent form of this equation in order to put it into standard form. So the reason why we want to do this, first of all, we want to look and see why do we recognize this as the equation of a circle, and we recognize it because it's in general form. We have an x squared and a y squared by themselves. We've got then x and y terms and a constant term. This is the sort of equation that we can rearrange into standard form. Now let's see how. We're going to use a process known as completing the square. And I mentioned this once before when we were looking at the quadratic formula, but let's see it again. So the general process of completing the square looks like the following. If I have x squared plus bx for some number b, and if I manage to add the expression b over 2 squared, then that expression is actually a perfect square. This is x plus b over 2 squared. And we can check this just by foiling out the right-hand side. So the way that we're going to use that in this equation is the following. We're going to take our general equation here, and we're going to start off by rearranging it so that all the x terms are together, all the y terms are together, and we've moved the constant term to the other side. So first step is we do all this. We've added 14 to both sides, and we've grouped the x's together and the y's together, and you'll notice I've also left a little bit of space after the x term and the y term. So now what I'm going to do is for this 6x term, what I'm going to do is I'm going to add 6 over 2 squared. I'm going to take the coefficient of x, I'm going to divide it in half, and then square it. And when I do that, I get 9. So I'm going to add 9 to this expression here. And what that's going to do is it's going to turn x squared plus 6x plus 9 into a perfect square trinomial. We are going to be able to factor this whole expression as a perfect square. And let's do the same thing over with the y's. Again, I'm going to take the coefficient of the y's. I'm going to divide it in half and square it. Let's see, negative 10 over 2 is negative 5. Negative 5 squared is 25. And I want to add 25 to this. And now the whole y piece here, y squared minus 10y plus 25, is going to factor as y plus or minus something squared. Now, of course, I can't just do these things. I have to back them up with balancing things out on the other side of the equation. So because I wanted to add 9 and 25 on the left side of the equation, I have to add 9 and 25 on the right-hand side of the equation as well. Good news, of course, being that we can. We're allowed to add the same thing to both sides of an equation. Now, x squared plus 6x plus 9 factors as x plus 3 squared. That's what that whole trinomial turns into. Y squared minus 10y plus 25 is y minus 5 squared. And then 14 plus 9 plus 25 is 50. Oh, no, let's see, what did I do? Sorry, not 50, 48. Bad mental arithmetic. 48. And so now we've managed to take our equation that was in general form and we've put it into standard form. And so now we can see that this is the equation of a circle with center -3, 5. Because that's the h and k that we read off from the equation, x minus h, y minus k. And radius, the square root of 48, which we do want to simplify down. The square root of 48, 48 is a multiple of 16. So 48 is 16 times 3. The square root of 16 is 4. So the radius of this circle is 4 times the square root of 3. So it's a circle with center -3, 5 and radius 4 times the square root of 3. So this is the basic idea for how we graph a circle that has been given to us in general form, where we have to translate it back into standard form. All right, so the last example I want to do has us doing a little bit of work before we actually can write down the equation. Let's write the general form of the equation of a line, of a circle, rather. We've already done lines, which has a diameter with endpoints 0, 2, and 7, 0. So let's sketch out what this looks like now. Here we're not told the center or the radius directly. What we are told is 2 points that lie on a diameter of the circle. So 0, 2, 1, 2, 3, 4, 5, 6, 7. So we're told that this blue segment is a diameter of the circle, which means it goes straight across the circle and passes through the center. And that's what we're going to use to fix this. If we have a diameter, then the midpoint of that diameter is always the center of the circle. So the midpoint of a diameter is always the center of the corresponding circle. So the first thing that we want to do is find the midpoint of the segment with coordinates, or the segment whose endpoints have coordinates 0, 2, and 7, 0. And remember that the way that we do this is we basically just take the average of the x coordinates, the average of the y coordinates, and that gives us the midpoint of the circle, of the diameter, which is the center of the circle. So for us, that means that this point 7/2, 1 is actually the center of the circle. Of course, now we need the radius. And to get the radius, what we can do is find the distance from the circle to any point on the exterior of the circle. And we know two of them. We know 2 points on the exterior of the circle, so we can just use one of them. So the radius is the distance from the center to any point on the circle, and I'll pick 0, 2 as an arbitrary choice. You could also have picked 7, 0 just as well. Which is, we can use the distance formula. We want the distance from the center to 0, 2. So we'll take the difference in the x values squared, so 7/2 minus 0 squared, plus the difference in the y values squared. So that's going to be the square root of, now 7/2 squared is going to be 49 over 4. And then 1 minus 2 is -1. -1 squared is 1. So we get the square root of, now 49 fourths plus 1. 1 is 4 over 4. So 49 over 4 plus 4 over 4 is 53 over 4. And we can simplify that down a bit. That's the square root of 53 over 2. So that means that we can write down the equation of our circle in general form. Now we're going to get to general form by going through standard form, and so as not to clutter this page up anymore, we'll go ahead and take the data that we found and move it to a new page. So we know that our center is going to be at 7/2, 1. We know our radius is the square root of 53 over 2. So that means that the standard form of the circle looks like x minus 7/2 squared plus y minus 1 squared equals the square root of 53 over 2 squared. This is the standard form, although we'll go ahead and simplify that right-hand side a bit. Square root of 53 over 2 squared means we square the top and the bottom, which means we'll have 53 over 4. Now, to get general form, we're going to expand all this out. And if we multiply this out, let's see, we've got x minus 7/2 times x minus 7/2. We need to FOIL that out. So we'll get x squared minus 7/2 x minus 7/2 x plus 49 over 4. So these two together just make negative 7x. So the first part of this will be x squared minus 7x plus 49 over 4. And then y minus 1 squared, that's a little bit easier. That's y squared minus 2y plus 1. And then 53 fourths over here. We will be combining things together. So on the left, we'll simplify and get x squared plus y squared, gather the squared terms together, then minus 7x and minus 2y, then the single variable terms together. Now 49 fourths plus 1 simplifies to 53 fourths. And we see now that when we gather everything on the left, in fact, the constant terms are going to cancel, and we'll just be left with x squared plus y squared minus 7x minus 2y equals 0. And there's our answer. That is the general form of the circle with that passes through the points whose diameter has a diameter with endpoints 0, 2 and 7, 0. We can see the 2 here and the 7 here showing up very suspiciously, so there may in fact be some general formula that you could come up with, some general theorem that says that if you've got a diameter that goes from this point on the x-axis to this point on the y-axis, then the equation has this particularly nice form. But we're not going to be trying to do anything like that. So these are the things that you need to know in order to graph circles and come up with the equations of circles based on their graphs.